All right, so in this video, we're going to start talking about complex numbers. A complex number is a number of the form a plus b times I, where I is the imaginary part. I is the same thing as the square root of -1. Okay, so in problem 11, we're going to simplify each expression and write the answer in terms of I. So the square root of -5, that's not a real number, but that's an imaginary number. So I got the square root of -5 is the same as -1 times 5. And by my rules of radicals, I can split the radical into two radicals and say this is the square root of -1 times the square root of 5. Now the square root of -1, that's what we're calling I. So I root 5, that would be the same thing as the square root of -5. The square root of -36. Well, -36 is the same thing as -1 times 36. And the square root of 36 is 6. The square root of -1 is I. So 6I would be my answer there. Okay. Now, usually when we have a number that involves an imaginary part, if the number is, if the real number part does not contain a radical, like this number here, 6I, usually we write I after the real number part. Although you can write it before it if you want. So you could say, this is the same thing as I times 6. Okay. Now, usually when we have a number that does contain a radical, like with this one, usually we write I in front of the radical. Although there's not a problem with writing the square root of 5 times I, it's just, we don't want to make it so that I looks like it's underneath the radical, because it's not. It shouldn't be underneath the radical. Okay, so to avoid any confusion with that, is I underneath the radical or not? We just write I in front of the radical. That way, the whole thing is a non-issue. Okay, I is not supposed to be underneath the radical. Okay. Part C. So I got negative the square root of -17. Well, the negative has to stay in front of the radical. The square root of -17, that'd be the same as I root 17, right? So negative I root 17, that'd be my answer. Okay. How about the square root of -24? Well, that's the same as I root 24. Now, root 24 breaks down. Okay, and just like anything else in math, simplify things as far as possible. Everything, okay? So root 24, that's the same as the square root of 4 times 6. The square root of 4 is 2, right? So 2I root 6, that would be the simplified version of I root 24. Okay, and that'd be my answer. How about the square root of -40? So that's the same as I root 40. And root 40 is going to break down. Okay, if we use 4 and 10, square root of 4 is 2. So 2I root 10, that'd be the answer. Okay. Negative the square root of -28. Okay, well, the negative is in front of the radical, so I'm going to have a negative number, right? At negative I root 28. And root 28 is going to break down. If we use 4 and 7, the square root of 4 is 2. So negative 2I root 7, that'd be the answer. Okay? Now, I guess unless you're told otherwise in these problems, go ahead and simplify things as far as possible. Okay, so if I get a negative underneath the square root sign, I'm going to simplify that. I'm not going to say no real solutions. I'm definitely not going to say no solutions. Right? Here's the solution. Okay? So, just continue to simplify things as far as possible there. Problem 12. Write the number 4 plus or minus the square root of -8 over 2 in the form a plus b times I. Okay. I got 4 plus or minus the square root of -8. That'd be an imaginary number. I root 8 all over 2. Root 8 is the same thing as 2 root 2. Okay, so now I'm looking at 4 plus or minus 2I root 2 all over 2. And let's see, 2 is in common to these two terms, so I can factor that out of the whole thing there. If we pull a 2 out front, the leftover from the first part is 2. 2 times 2 is 4, right? And then 2 times I root 2, that'd be 2I root 2. And that 2 that was brought in front, I can cancel that with the 1 down under. So that's going to leave me with 2 plus or minus I root 2. Okay, and that would be as simplified as I can get things there. So I'd circle that result. Okay. Now a plus or minus b times I, that's a complex number. Okay, now up here, I was talking about imaginary numbers. Okay, now there's a systematic way that everybody in the world learns about our numbers. Okay, when you first start working with numbers, you work with natural numbers or whole numbers. Right, whole numbers are 0, 1, 2, 3, 4, etc. And then after that, you learn about integers. So they're the whole numbers, and then they're negatives. Right? So I got 0, 1, 2, 3, 4, and then -1, -2, -3, etc. Okay, and then I learn about fractions. Okay, the set of all fractions is called rational numbers. Okay, just fancy words for fractions. And so what do I have to do? I need to make my set of numbers bigger. So I got to throw in all these fractions now. Okay, and then after that, I learn about numbers that are not written as fractional form, like pi. There's no way to write pi as a fraction. Or the square root of 2. There's no way to write the square root of 2 as a fraction. Okay, or the square root of 3. There's no way to write the square root of 3 as a fraction. Or the square root of 4, is that a fraction? No, the square root of 4 is 2, and 2 can be written as a fraction. Right? I just throw 1 in the denominator. 2 over 1, that's the same as 2. So I'm not just picking any square root. Okay? Certain ones, I can't write in fractional form, and certain ones I can write in fractional form. So now if I take all the rational numbers, fractions, and all the irrational numbers, ones that are not fractions, and I throw them all together in one big pile, then we call that the set of real numbers. Now, a real number is any number you've seen thus far. And yet again, we are making our set of numbers bigger. Now, why are we doing this? Well, because I need to throw in numbers of the form a plus b times I. Now, why in the world would I ever want to do that? Well, it all revolves around solving equations. Okay, so if I want to be able to solve, like this equation here, let's say x squared equals -1, I have to know what a complex number is. If I have no idea what a complex number is, then this equation has no real solutions, and that'd be my answer. But no real solutions does not mean no solutions, right? This equation has a solution. It's plus or minus square root of -1, or y equals or x equals plus or minus I. Okay, that'd be the answer. Okay, now it's just like this. So if I had the equation 2x equals 1, and I want to solve that for x. So in order to solve that for x, I need to know what a rational number is, right? If I have no idea what a rational number is, if I've never seen that before, then I would say that this equation has no integer solutions. No integer solutions does not mean no solutions, though. Right? Like this equation has solutions. It just involves numbers that you have to be familiar with. Okay? And in an algebra class, you solve a lot of equations, right? So, these imaginary numbers, or these set of complex numbers, that's going to be, the next biggest set of numbers. Now, the set of all complex numbers involves all the numbers of the form a plus or minus b times I. Okay? So, now any real number is always going to be a complex number. like you guys have been working with complex numbers your whole life. Because if a and b are any real numbers, that includes 0. So like, I could write a number like 7 as a complex number. I'd say 7 plus 0 times I, right? I don't normally write plus 0, but I guess I could. Okay, if a and b can be any real number, that includes 0, right? So again, you guys have been working with complex numbers your whole life. Okay, now we're gonna get some practice working with complex numbers where b is not 0. Okay, b is going to be other numbers. So let's take a look at problem 13. We want to write the following and write each answer in the form a plus b times I. Okay, so in part A, I'm adding two complex numbers together. Whenever I'm adding or subtracting complex numbers is really easy. All I do is I combine the real number parts and I combine the imaginary parts together. Okay, so let's do that. You got negative 7 plus 2 is negative 5. 3i minus I, that's 2i. So there's my complex number, negative 5 plus 2i. I'd circle that. Now, what if I'm subtracting these two numbers? I got 5 minus 6i minus 3 plus 4i. So 5 minus 3, that's 2. Negative 6i minus 4i, that's minus 10i. And there's my complex number. A is 2, b is negative 10, right? And so I could circle that. Part C, I got 8 plus I times 3 minus 2i. Okay, well, the natural thing to want to do there is to FOIL this out. So 8 times 3 is 24. Negative 16i plus 3i is negative 13i in the middle. And then I times negative 2i is negative 2i squared. Now, I squared is the same thing as negative 1. So really what's going on here is I'm really at the end, I'm adding 2. Okay, so 2 plus 24, that's 26, minus 13i. 26 minus 13i, that's my answer. Okay, now keep in mind that you're not done with the problem yet until you're in the form a plus b times I. So I wouldn't just circle this. This is not in the form a plus b times I. Okay, some students do that. So, okay, part D is an example of dividing complex numbers. So whenever I add, subtract, multiply, or divide complex numbers, the end result is always going to be a complex number. Okay, so again, I'm not done with the problem yet until I'm in the form a plus b times I. Now, in the case of division, the way to do this is to multiply the top and the bottom by what's called the conjugate of the denominator. Okay, so 5 minus I, that's in the denominator. The conjugate of that would be where I just change the b value to its opposite. So b would be negative 1, right? And so I'm going to multiply the top and bottom by 5 plus I. Now 5 plus I over 5 plus I, that's the same thing as 1. So I'm not changing this number, right? I'm changing the form. I'm not changing the actual number, though. If we FOIL out the top, 4 times 5 is 20. And then 4i plus 5i, that's 9i in the middle. I times I is I squared at the end. And divided by 5 times 5 is 25. 5i minus 5i, that's 0 in the middle. That's what I want, by the way. Negative I times I is minus I squared. I squared, again, is negative 1. So really what's happening in the denominator here is I'm really adding 1 to 25. If I squared is negative 1. I got 25 minus a negative 1, that's 26. Up top, I'm really subtracting 1 from 20. 20 minus 1 is 19, and then plus 9i. Okay? Now notice how we have 26 showing in the denominator. Okay, so anything involving I went away completely in the denominator. That's what I want to have happen. So sometimes I see where students will multiply the top and bottom by 5 minus I. You don't want to do that, right? Because 5 minus I times another 5 minus I, that'd be 25 minus 10I plus I squared. So the problem with that is that I still have a plus 10I showing in the denominator. And I want to make anything involving I go away in the denominator. Okay, so I've done that. And now technically I'm not in the form a plus b times I because I have this division by 26 going on. Let's go ahead and split this fraction into two fractions that are added. So I got 19 over 26 plus 9 over 26 times I. Okay, so A would be 19/26 and B is 9/26. And I'm done. I'd circle that number there. Okay. So that's a little bit with the operations with complex numbers. Why don't we go ahead and stop the video right there, and I'll pick up with problem 14 in the next video there.